Okay, hello everyone. Now we are going to start the training today. And first thing I want to check, you can overhear my voice, right? Yes, okay. Okay, and firstly, please allow me to introduce myself. My name is Alex, and if you have ever watched the video of RCNA WLAN, I think you have known me before, right? And this time, since it's a public training for this month, and the topic is, as you can see on the screen, is about the summarization of RCNA WLAN. And if you have already finished the learning on no matter YouTube or on our e-learning platform, I think this course will help you get deeper understanding of how does WLAN works, and how, for example, how can we modify some features in WLAN, or how can we even change some configurations and make it more suitable for our network or for our users. And if you didn't finish the learning of this course, you don't need to worry about it, because I think even you didn't finish the course, after learning this summarization training, I think you will have maybe totally understanding of this course, and then you can watch the videos by yourselves and know maybe the detailed information in the e-learning in the YouTube. Okay. And now let's start this training. Firstly, let's see the forward here. After finishing the learning of RCNA WLAN, I think and I believe that you can use some devices, for example, an AC. AC is the access controller, and the AP, the access points. And except that, we should use some switches, and maybe in some large networks, even we need to use some routers, or maybe EG and even firewalls. And by using these kind of devices, we can build a network and can offer a wireless access for our users, right? And except that, after learning RCNA WLAN, I think you will be able to manage your signals. For example, the band you use, the channels you use, and we can change maybe the SSID, right? Except that we can maybe deploy some authentication to our users to avoid some unauthorized users to access the network, right? And in this course, we will summarize the technical content of RCNA WLAN. Means that we are going to review the content in RCNA WLAN together. And except that, I prepared a typical network for you, and we will finish the configuration of this network together. Okay, this is about the content in this course. And the typical network I have just mentioned is what you can see here. Even the structure is quite simple, right? We only have two switches. We have a core switch, an access switch, and except that, we have two APs, right? Maybe AP1, AP2, and we have an AC to manage all these APs in the network. And in this network, you can also see some technologies or some protocols we are going to use. For example, static root, because this is layer 3 networking. So between the AP and ACs, there must be some rules to allow the communication between them. So what we use is the static root. And except that, on the core switch, we should enable the DHCP service. And the DHCP service is used to assign the IP address to each AP, because each AP should have a management IP address. And for some STAs, for some clients that access the network, they could get their IP address through the DHCP server, the core switch here. Except DHCP, we're going to use the DHCP option to assign the IP address of AC to each AP. Because after learning the RCNA WLAN, I think you must know that between the AC and the AP, they should establish a kappa terminal, right, between the AP and AC. And actually, between each AP and the AC, they should establish a kappa terminal. And to establish a kappa terminal, the APs should know where is the AC. Where, actually, here what we see where represents the IP address of AC. So by using DHCP option, we can assign or we can tell all the APs that the IP address of AC is, for example, 1.1.1.1 or other IP address, right? Okay. And on the switches, no matter the core switch or access switch, we should configure the VLAN, and we should, for example, we should set a VLAN specifically used for the management of AP. Right? For example, APs belongs to VLAN 30, and for each WLAN or for each SSID, they could have at least one VLAN. For example, for SSID employee, the VLAN is 10. For SSID guest, the VLAN is 20. So this is a function of VLAN in the WLAN network. And on AC, we also need to configure the static rules, and except that the most important is some WLAN basic technologies. For example, the SSID, for example, the band, the channels we're gonna use should be configured on AC. And we should establish the kappa terminal, and we should enable some WLAN security technologies, no matter for the authentication of users or for the maybe user isolation between STAs, or we should even use some, no matter whitelist or blacklist, to avoid the illegal STAs to access the network. Okay, so the objective of this course is to know the protocols, the technologies we use in this topology, and except that we should know how to configure or how to deploy this project. Okay, and next, let's see. What we just introduced actually is the technical requirements, and the next is the service requirements, or even you can think that this is the requirements of service or requirements of the users of the terminals. First is that to facilitate the network management, we should provide employees with a wireless network. The name is employee. And for some guests, for example, some guests of your company or some guests of the maybe of your office, of some maybe shopping malls and so on, we should use another WLAN, which SSID is guest. So in this way, we can distinguish these users. And for different type of users, we can maybe enable different kinds of security technologies, right? And in order to manage access users, the employee network use WPA2 PSK authentication, while in this case, for the guests, the authentication type is open, okay? And to enhance the overall security of the network, guest enables user isolation and adds the illegal STAs to the blacklist. And lastly, actually, is the roaming technology, which is used to prevent the service interruption when we move inside the WLAN, right? For example, we are moving from the coverage of AP1 to AP2. So in this process, to prevent the service interruption, we can use the roaming technology. Okay, this is about the service requirements. And next, let's see the technologies we use to maybe establish this kind of requirements or to satisfy this kind of requirements. Okay, first is the IP addressing and IP address planning. Because for different users or for APs, they should get their own IP address. So before we configure the device, we should plan the IP address we could use. And next is the 802.11 standards. Actually, this is a standard for the WLAN and some capable principles. For example, how to establish a capable terminal and the process of establishing a capable terminal and of course the configuration, right? And at layer 2, the main technology we use is WLAN, and at layer 3 is static routes. And we will use other technologies, for example, DSCP option, and for the advanced WLAN technologies, they are authentication, user isolation, blacklist, and whitelist. So in the following content, we are going to introduce most of these technologies one by one. Okay, and if you have finished the learning of RCNA WLAN, you could find that actually what we can see here is the main content of the RCNA WLAN, right? Okay, firstly, let's get to the content. First is about what is WLAN, or we can also see that the definition of wireless local area network. It uses the radio frequency technology to replace the wired length. Means that for the wired network. Okay, for the wired network, we use some maybe wired cables, right? We use some maybe fiber cables, right, or the copper to connect the devices or to connect the network device with the terminals. But for a wireless network, for WLAN, what we use is the radio, right? And the STAs is connected with the AP through the air and by using some radio technologies. So WLAN can use simple access architecture to let users send and receive information anywhere. This is also one of the advantages of WLAN. So let's see. The first advantage of the WLAN is that it's flexible and the mobility is very obvious. Because if you use a wired network, for example, if you use a cable to connect your PC with the access switch, you cannot move, right? You cannot move. But if you use your mobile to connect with a WLAN, you can move freely. You can move freely inside the coverage, right? And it makes it more flexible. And the second advantage is that is the easy network planning and adjustment. Because all the APs are centrally managed by AC. So when we plan the WLAN network, when we maybe adjust the planning or the structure of the WLAN network, the main point is the AC. And since it's centralized managed, so it becomes more convenient for us to do that. And the third advantage is the easy expansion. Here, expansion have two situations. For example, first is that we should expand the coverage of the WLAN. It's quite easy, right? We just need to add more APs and deploy these APs in a larger area, so we can expand the coverage of it. Except that in another situation, we want to expand the functions support by the WLAN. For example, we should have another SSID. So we just need to add the configuration of another WLAN on the AC. Right? For example, if we only have WLAN which WID is 1, so if we need another one, so we can configure WID 2, WID 3. So in this way, we can expand the WLAN network, and we can have maybe more SSIDs for different types of STAs or different types of users. Okay.
Book cover keyboard.
Okay, and next is the easy fault locating. No matter it's a wired or wireless network, actually is maybe a little difficult for us to do the troubleshoot, right? To troubleshooting, and for the wired network, we should maybe understand the working principle of each protocol of each device, and we should have a deep understanding of the configuration on different devices, so we can analyze the output or the philosophy or the outputting of the trouble, and then locate the faults, right? And for the WLAN network, actually is similar, but why we see that it's more easier because we can have more tools for us to locate the fault in the network. Because, for example, nowadays we have cloud, we have for the SME we have cloud, right? For the GE we have WIS, or even we have some other tools can help us locate the faults. And in other words, since the WLAN is centralized managed, so we can do some troubleshooting centralized on the AC. It's more convenient, more easier for us to locate the faults. And for the installation, it's more easier actually compared with the network. We have reduced a lot of cables, so the installation will be simpler, will be easier, will be more convenient. Okay, so this is about the definition of WLAN and some, how can we see, some difference or some advantages of WLAN. Okay. After knowing this, next let's go on to the next part. With time passing by, actually, WLAN has going through a lot of generations. What we're using nowadays is Wi-Fi 6 or Wi-Fi 5, right? And with the development of the WLAN technology, in this table, you can easily find that. Firstly, the bandwidth has increased a lot, right? The bandwidth has increased a lot. For example, in Wi-Fi 1 is only 20 megabits, right? While nowadays it's up to 160, right? But the frequency we are using is similar. We are using 2.4 gigahertz and 5 gigahertz bands. And the maximum rate has increased a lot, actually. You can see the maximum rate nowadays we support in Wi-Fi 6 is up to 9.6 gig BPS. It's a quite high rate, right? And the spatial streams we support in Wi-Fi 6 is 8, right? Actually, this is also the reason that the maximum rate has increased a lot, right? Because we support more spatial streams nowadays, based on, for example, based on different technologies. And the standards, which is related to Wi-Fi 6, is IEEE 802.11ax, and Wi-Fi 5 is 802.11ac. Okay, so from here you can know that no matter the bandwidth or the rate has increased a lot based on the development of the WLAN technology. Okay, and here we mentioned the concept, which is called the frequency. For example, 2.4 gigahertz, 5 gigahertz. And in the WLAN, actually, it has another concept or another name. It's called band. So what is band, and what's the difference between 2.4 gigahertz and 5 gigahertz? Let's see it. Firstly, if we want to send or if we want to use the WLAN or the wireless local area network to send packets. The whole process is showing here. You can see this is the source of the signal. We call it signal source. And after modulation, you can see the radio transmission device will send out this signal through the, you can see, through the channel and the media. The media, of course, is the air. And here is mentioned a concept called channel. Okay. And later we're going to introduce what is channel and what's the relationship between channel and band. Okay. And then no matter how that works, but the receiving device has received the signal. And after demodulation, the information will be sent to the signal host. And the signal host will receive it and operate maybe the information inside and get the information they need. Okay, and on the other direction, actually is the same, but the signal host becomes the signal source and send it to the maybe to the transmission device, and transmission device sent to the receiving device. It's actually the same. But what we should pay attention here is two concepts. First is the band. As we already know in the former page that the band we have nowadays is 2.4 gigahertz and 5 gigahertz. So what are they? Let's see. Band refers to a certain range of frequency. So 2.4 gigahertz band. Here, the number 2.4 is not, you can see it's not an exact number. It represents a range. And what's the range of it? Let's see. APs use 2.4 and 5.8 gigahertz band. Here, 2.4 and 5.8 gigahertz refers to maybe these two bands. And even since we have seen that if 2.4 represents a range, so what's the range of it? The 2.4 gigahertz band refers to the frequencies in the range of 2.4 to 2.4835 gigahertz. Okay, so you can see this is a range, right, from 2.4 to 2.4835, and in this range, there could be maybe different frequencies: 2.41, 2.42, 2.43. So all these frequencies belongs to this range. A band includes multiple channels. Here comes another concept called channel. So from here we know a band includes multiple channels. So the frequency from 2.4 and 2.4835 has been divided into different parts. Each part you can think it's a channel. Okay, you can think it's a channel. A signal of an AP uses a specific channel of a band. So since we have multiple channels, let's see what is channel and how do we maybe distinguish these channels. If an AP uses the 2.4 gigahertz band, it uses the frequencies in this range. We have mentioned it. And in this range, we have 14 available channels. 14 available channels. But how can we maybe distinguish the frequencies in this range? There must be a rule. Here comes the rule. The standard frequency of each channel is 5 megahertz apart from each other. Okay, so for example, this is channel 1, this is channel 2. Or you can say this is the center of the channel 1, this is the center of channel 2. And the frequency difference between them is 5 megahertz. Okay, so the center of the channel is 5 megahertz apart from each other. And the bandwidth of each channel is 22 megahertz. For example, for channel 1, the bandwidth is 22 megahertz. For channel 2, it's also 22 megahertz. And and I think here you may get a little confused, or it's a little complicated. complex. Let's see it. Here, what you can see actually is the 14 channels in 2.4 gigahertz band. You can see this is the channel 1, channel 2, channel 3. Because the center of channel 1, you can see the center of channel 1 and the center of channel 2 is 5 megahertz. Right? It's 5 megahertz apart from each other. So here is 5 megahertz. You can see the center frequency of channel 1 is 2.412, while that of channel 2 is 2.415. From the number, we can also know that the difference is 5 megahertz. Okay, and from here we know that, or even directly, when we directly see the picture, you can see these parts of channel 1 and channel 2 is the same, right? They use the same frequency. And for channel 1 and channel 3, it's the same. You can see for channel 1 and channel 3, this part have the same frequency, right? Same frequency could cause some problems. And the problem, we call it interference. We call it interference. For the APs use the channels that interfere each other, it will affect the user experience in the WLAN network. So this is also what we should do to optimize the WLAN. For example, we can adjust the channels we use. Okay, so what we can do to avoid interference in the WLAN network, we just need to find some channels that will not interfere each other. And from the picture, we can easily find out that. Let's just clear the mark on it. Okay, you can see channel 1 and channel 6. You can see channel 1 and channel 6 and the channel 11. Actually, they don't have any frequencies, or they don't have any parts that have the same frequency. So it means that between channel 1, channel 6, channel 11, there will not be any interference exist. Right? There will not be any interference. And for channel 2, channel 7, channel 12 is the same. For channel 3, channel 8, channel 13 is also the same. So here I think you can get an idea. In the real network, maybe since there could be a lot of APs, and if all these APs are using the same band, are using the 2.4 gigahertz band, it's possible for some of them are using the same channel, or for some of them are using the channel will interfere each other. For example, some of the APs is using channel 1, while some others are using channel 3. There could be some interference. And to optimize the network, what we should do, one method to optimize the network is to detect, for example, now I can use a tool to detect that how many channels, or what are the channels are using at this place. For example, the result that some APs using channel 1, some APs using channel 2, some APs using maybe channel 6. Okay, but to reduce the effect of interference at this time, we can adjust the channel of our own APs. For example, we can use channel 11. And then you can manually change the channels by some commands on the AC. This is how to manually adjust the channels. But it's very complex because we should detect the channels first, and then we should manually maybe configure it, manually adjust the channels. So most of the tools nowadays, no matter the cloud we use or no matter which we use, you can use the one-click optimization, and after using that, the tool, the platform itself will do the same work. Actually, it will automatically detect the channels, and then will automatically adjust the channels we use. Okay, so this is about the interference that could happen in the WLAN and the way to maybe to reduce the effect of interference or to avoid the interference in the network. Okay, and then let's go to the next part. Next is some other concepts. You can see the first we should know is the SSID. Okay, here we have two APs, right? We have two APs, and they have the same SSID, which is office. The SSID in the network actually is the, you can think that this is the name of the wireless network. For example, if you set the SSID to be office, you can use your mobile to maybe to connect to the WLAN, to search the WLAN, and you can find that, okay, there is the Wi-Fi, which name is office. So SSID is the name of the wireless network. And except SSID, next is the BSS and the BSSID. Okay, BSSID is the MAC address of the AP. Okay, so SSID is the name of Wi-Fi, and the BSSID is a MAC of AP. And BSSID actually is the identifier which used to uniquely identify each access point. Because we use the MAC address of AP1 to be the BSSID of AP1, and MAC AP2 to be the BSSID. So we can distinguish them based on the BSSID, right? And since the MAC address is uniquely, so we can uniquely identify them, okay? And last is the ESSID. Normally, the ESSID is the same as, actually is the same as the SSID, okay? It's the same as SSID. And for all the APs that have the same SSID, you can think they are in the same ESS. Okay. So this concept of these three different parameters, and you should know the difference between them. And of course, for the SSID, you should know how to configure it by using commands. Okay, later we will see the command to configure it. And if you think that it's a little difficult to understand, or we can have an example, and you can think that the SSID is the how can I see? It's the name of a company. For example, it's Ruijie, right? The SSID is the name of a company, it's Ruijie. And all around the world, we have a lot of maybe stores, or we have a lot of offices. Right? The name of them actually is also Ruijie, right? For example, the office in China, we have a lot of offices in China, and they have their own name. And since they belong to Ruijie, so their name is Ruijie. But BSSID, you can think, is the location of the address of the offices. Okay, the address of each office, you can think, is the BSSID. Well, what's the ESSID? For example, since nowadays we have services, or we have a business in different regions, right? In different regions. So ESSID actually represents the, for example, our shops, our offices in different regions, and ESSID actually is the region. Okay, so I hope that by this example can help you maybe easier understand these three concepts. Okay. After knowing these three concepts, then let's see some typical WLAN architectures. Here, what you can see are three different architectures: direct connection, layer 2 interconnection, layer 3 interconnection. And obviously, the difference is the network between AC and APs. Direct connection means that now we are using cables to directly connect the AP with the AC. We use physical cables and directly connect, for example, AP with the G01 of AC and connect the AP2 with the maybe G02 on the AC. This kind of architecture is called direct connection, but actually in the network is seldomly used, right? Seldomly used because the port of AC is limited. What does AC? Sorry, I see a question in the group chat. Says what does AC means, right? AC is the access point. Access controller. AC is access controller, which is responsible for the control of all APs, and in some cases, it's also responsible for the data forwarding. It's based on the data forwarding mode in the WLAN. Later we will use it. Okay, and then let's see. We just said that the direct connection is seldomly used in the real network because the number of ports on AC is limited. Even for some enterprise ACs, they have fewer ports that can be used to connect with ACs. But normally in the network, we have a large number of APs to cover maybe a building, even a campus. So we must have maybe some switches here. We must have some switches or other network devices to extend the network. Okay, to solve this problem or to satisfy this kind of requirements, layer 2 and layer 3 interconnection are mostly used. While the typical application scenario of layer 2 interconnection is that between the AP and AC, we have some switches, and these switches are layer 2 switches, right? Or even they are layer 3 switches, but the AC and the APs are in the same layer 2 network. So we think this is a layer 2 interconnection. While for the layer 3 interconnection means the AC and APs are not in the same subnet or are not in the same layer 2 network. And if we use the layer 3 interconnection, pay attention here, we must have some routes, right? We must have some routes to guide or to establish the communication between the AP and AC, because we say that between the AP and AC, they should establish a cap-up tunnel. Right? To establish the cap-up tunnel, at least they should communicate with each other. So in a layer 3 network, to establish the communication between them, we must have some routes. And it could be some maybe static routes in small networks, or it could be some dynamic routing protocols in some large networks, right? Okay, so this is the typical WLAN architecture, and we have 3 types. Okay, and in the lab of this course, later we are going to introduce in the lab of this course, what we use is the layer 3 interconnection. That's AP and AC are not in the same subnet. Okay. Okay. After knowing the network architecture means, or after we have after finishing the connection of devices of cables, next we should know how does the AP and AC establish the cap-up tunnel. Okay, what you can see on this page is the whole process. Let's see. Okay, firstly, the AP should obtain the IP address of AC. because we said that to establish the kernel, AP and AC should communicate with each other. And to communicate with each other, they should know the IP address, the IP of each other. Okay, since in the WLAN network, you can see in the following steps, AP discovers the AC. So firstly, AP should know the address of AC. And how does AP know the IP address of AC? What we use is a DHCP, right? DHCP. The APs firstly should get their own IP address. So on the network, there must be a DHCP server. And the DHCP server could be the core switch, or the DHCP server could be the maybe even the AC, right? And after getting the IP address of their own, APs should know the IP address of AC. And this is established based on the DHCP option 138. And next, after knowing the IP address of AC, then AP discovers AC. Means AP will send the discover message to the AC to the IP address we got from the DHCP option of 138. This process is called discovery, right? And the next, AP requests to join the AC. This is called join. This step is called join. And after receiving the request from APs, firstly, AC should confirm the version of AP. Okay, the version of AP. Here, the version means the version of the framework. Okay, sorry, firmware. The version of the firmware on AP. And here it says that the AP is automatically upgraded. This step is optional. Okay, this step is optional because this step is triggered. It's triggered only when that the AP's version is not allowed on AC. Okay, for example, after receiving the request from the AP, the AC find that okay, the version of the version of the AP is not the latest version. So at this time, the image data process will be triggered. Triggered means that AP will automatically upgrade its version, and then it will repeat this process to request to join the AC. Okay, so about the image data, you should know this step is optional, and the function is to upgrade the AP. Okay. And next is a configuration. After joining the AC will deliver the configuration to the AP. Okay. This is the configuration state. At this stage, obviously the AC will deliver the configuration to all the APs. For example, the configuration of VLAN, the configuration of the maybe some advanced features, for example, authentication, for example, blacklist, whitelist, and so on. Right? This is for the configuration. And the next is a data check. Data check means that the AP confirms the configuration received from the AC. And the last step is run. It's run state. The AP and AC forward data through the kernel. Okay. Here, let's just by the way, let's see it. The forward data, the data forwarded inside the kernel can be divided into two types. Okay, the data here. First type is the service data. Service data means, for example, you are using your mobile, connecting with the WLAN, and you are watching some videos, or you are maybe chat with some others. So the traffic generated by this kind of applications is called service data. And except that some data could be the control messages. Control messages means the messages or the data between the AP and the AC, right, to control, maybe to send some configurations or to send some control messages, keep alive messages between the AP and AC. Okay, it's not related to the service in the network. Okay, so this is about the establishment of the Kappa kernel. And in this process, what we should configure or what we should pay most attention is the first step. How does the AP obtains the IP address, and how do we configure, right? How do we configure the DHCP and DHCP option on the DHCP server? Let's see it. The DHCP, you can see the DHCP service is offered by the DHCP server in the network. And the DHCP server could be, for example, could be a core switch. Not a core switch, could be a switch. Or it could be an AC. Okay, it could be any devices that support the DHCP function. Okay, and then between the DHCP server and the AP, at this time, since AP is asking the IP address from the DHCP server, so AP has another name is for DHCP client. And between the DHCP client and the DHCP server, they will exchange some messages: discover, offer, request, and egg. Okay. About this process, since we have introduced it in the RCNA RS and in the RCNA WLAN, we also mentioned it. So we will not introduce the detailed information here, but you should know that in the acknowledgement sent from the DHCP server and the DHCP to the DHCP client, it contains some information, for example, the IP address. Okay. It contains maybe the lease time, right? And if you configure, it contains maybe the gateway, DHCP server IP, and so on. Okay. And what we should pay attention here is the configuration of the DHCP. Firstly, service DHCP. This is used to enable the DHCP service on the device. And then IP DHCP port, AP/IP. Here, the first part is fixed. IP DHCP port. And the following part is the name of the port. This is a name. So you can maybe set any name you like. Here, the name is AP/IP, means this is the IP address port for the APs. And the next, network. Network means the range of the IPs that we could use in this address port. Okay, 172.16.1.0, and the mask is 255.255.55.0. Okay. And it represents that in this address port we have about 253 address can be used. The reason why it's not 254 is that one of the IP address in this subnet is used at the gateway and cannot be used or cannot be assigned to the DHCP client. So to specify the gateway, the command is default router following with the IP address of the gateway. Okay. This part is the common configuration of DHCP. And the last part is very important. Option 138, IP 1.1.101. Okay, before the IP address, this part is fixed. Option 138 IP. And the next 1.1.101 here, it actually is the IP address on the AC. And this is also the IP address used to establish the Kappa kernel between AC and AP. Okay, so in this way, during the process of DHCP, the DHCP server will tell the AP that, okay, the AC's IP is 1.1.101, and by this way, AP knows the IP address of AC, so it will send the discover message to AC, right, to discover the AC in the network. At the discovery stage, Okay, so this is about this JCP option 138. You should know the function of it, and you should know the commands we use to configure it on the JCP server. Okay, and next, here comes to the WLAN data forwarding. Because since we have already established the Kappa terminal, means that the AP is online. Right? AP is online on the AC. Since AP is online, so AC can deliver the configuration to the APs, and after get the configuration, or based on the configuration, APs can send out signals, and we can use STAs to access the network right now, right? Okay, since we can normally access the network, so we must generate some packets, or we must generate some traffic. And how does this traffic forwarded in the WLAN? Let's see it. The WLAN data forwarding. The data forwarding of WLAN can be divided into actually two types. First is called centralized forwarding. From the name centralized forwarding, actually, we can know that there must be a center. Right? There must be a center in the network. So which is a center? Is here. It's an AC. AC is a center in the WLAN. And the centralized forwarding means all the traffic will be forwarded to AC. Here we have two types of traffic. We use two different colors to represent them. The yellow one means the data, okay? Data transmission. Yellow means, for example, for these APs, they have some STAs. Right, this is a mobile, right? And we are watching some videos. We're watching some videos on this mobile. It will generate some service traffic. And this service traffic will be sent to the AP. Right? AP will send to the access switch. Access switch will, after receiving that, access switch will, sorry, here. After receiving this, the traffic from the STA, AP will find that, okay, this is a WLAN traffic. And since between the AP and the AC, they have established the Kappa terminal, right? This is a Kappa terminal. So the traffic will be encapsulated and will be forwarded inside the Kappa terminal, and then be directly sent to the AC. And after receiving the traffic from the AP, AC will know that, okay, this is the WLAN traffic, and will decapsulate the packets, the traffic. And then AC will send it, find out, for example, will check the destination, and will compare the destination with local forwarding entries. For example, we'll check the IP routing table, and then send it to the gateway of the network and to the internet. Okay, and for the traffic, for example, for the traffic from the internet to the STA, let's clear it. The traffic from the internet will be sent to the gateway, and the gateway will send to the AC. AC will send to the AP through the Kappa terminal, and the AP will send it to the STA. Okay. This is the forwarding of the service traffic in the centralized forwarding mode. And since it's the control transmission is the control message between the AC and AP, so it must be forwarded through the Kappa terminal. So in the centralized forwarding mode, no matter the service data or the control message, both of them are transmitted inside the Kappa terminal. Okay. And for the local forwarding mode, let's say it's local forwarding. Local means the AP itself. Okay, AP itself. and compared with the centralized forwarding mode, or we just compare these two figures, we can easily find out that in the local forwarding mode, the traffic, service traffic, is sent, you can see, is sent locally, sent to, for example, AP will send it to the switch will check the forwarding entries and send to maybe to the aggregate switch, and the aggregate switch send it to the core switch will send it to the gateway. Okay. Means that it will not be sent to the AC through the type-up terminal. All the network devices that receive the service traffic will forward it based on the local forwarding entries, no matter the MAC address table or the maybe IP forwarding table or IP routing table, right? This kind of local forwarding entries. Okay, but for the control message, it's the same. The control message between the AP and AC is forwarded through the type-up terminal. Okay, this is about the WLAN data forwarding modes. And actually, by different, since the forwarding mode is different, there could be some difference when, for example, when the STA's rooms inside the WLAN, and it will affect, for example, if the AC is offline and how does the network works. Okay, later we will mention it. At this page, you just need to know how does the centralized forwarding works, how does the local forwarding works. Okay, and next, let's see the roaming. Since we just said that when the STA's roams in the coverage of the WLAN, different data forwarding modes could have different actions, could take different actions. So let's firstly, we should understand what's the meaning of roaming, right? What's the meaning of roaming? Now, let's see the figure on the left first. Now we have a STA, right? This is a STA, and the first study is associated with AP1. It's associated with AP1. And we assume that from the figure, we can see this is the laptop, right? This is a laptop. And for example, me, now I am maybe do the training in the meeting room. And of course, I'm connecting with the AP in the meeting room. But after finishing this training, I will go to maybe go to the office. So I will leave this room. And in this process, maybe you can see I'm leaving this room, I'm moving from left to right. And in this process, I'm getting more and more closer, right? Getting more and more closer to AP2. And on AP2, you can see on AP2, if it offers the same WLAN network, for example, SSID employee. On AP1 and AP2, they offers the same WLAN network, right? But during the moving of the STA, it can find out that, okay, at this time, for example, at this time, AP2 can offer a better signal, or AP2 can offer a better service quality. So at this time, I want to connect with AP2 because the SSID is the same. They are the same WLAN, same WLAN network. Okay, so let's see it. After moving to the AP2, STA will reassociate. Pay attention here, reassociate with AP2. And in this case, the traffic will be sent to AP2. If the forwarding mode, let's see, if the forwarding mode is centralized forwarding, and no matter AP1 or AP2, they are actually managed by the CMAC. So the traffic before roaming is sent from the STA to the AP directly sent to the AC. And after roaming, the traffic path is actually the same. The STA send it to the AP send it to the AC. Okay, so this is how does the packet forwarded at the layer 2 roaming and at the centralized forwarding mode. Pay attention here. No matter actually before roaming, the VLAN is VLAN X. IP address is A.A.A.A. And you can see that after roaming, the IP address is still unchanged. Okay, it's still unchanged. If the IP address of the STA has changed, for example, you have disconnect from AP1 and connect with another AP, no matter what's that, but you have connected with a new AP, and at this time you check that the IP address of your no matter laptop or your mobile has changed. The IP address has changed. You can see this is not roaming. Okay, this is not roaming. Okay, and the next is the how does the traffic forwarded at the layer 2 roaming when the forwarding mode is local forwarding. Okay, you can see here it's the same. The STA is moving from from AP1 to AP2, and it will reassociate with AP2, and the traffic of this STA will be sent to AP2. And since it's the local forwarding, it's a local forwarding, so AP will check the local forwarding entries and send it to the network, for example, to the switches, and the switches will locally forward these packets, this traffic, while we're not send it to the AC. Okay, this is about the definition of roaming and how does traffic forwarded at the layer 2 roaming situation. Okay, and next, let's see the layer 3 roaming. Before we introduce the layer 3 roaming, we should know the difference between layer 2 and layer 3. Okay, if it's a layer 2 roaming, means, for example, AP1, AP2, their SSID. Let's go back to the former page. Okay, let's go back to the former page. If it's a layer 2 roaming, means, for example, AP1 is SSID is employee, and on AP2 is also employee, but the associated subnet here is 192.168.1.024, and on AP2 is CM 192.168.1.0/24. So no matter before or after roaming, actually we are in the CM subnet. We're in the CM subnet, so this is layer 2 roaming. But in layer 3 roaming, even the SSID is the same. For example, employee. But the subnet here is 192.168.2.024. While for the employee on AP2 is another subnet, 3.0/24. So at this time, they are in different subnets. Different subnets represent different broadcast domain, right? Represent broadcast domain, and different broadcast domain represents they should establish a layer 3 connection between each other. So this is called the layer 3 roaming. And if it's a layer 3 roaming, pay attention here. The IP address after roaming is still unchanged. It's still unchanged. So this is the reason I say that no matter it's a layer 2 or layer 3 roaming, if you maybe switched to another AP and you find that the IP address of your terminal has changed, means that this is not roaming. Okay. So no matter layer 2 or layer 3 roaming, the IP address of the STA is still unchanged. Okay, and this page, let's see how does the traffic forwarded. How does the traffic forwarding? If the forwarding mode is centralized, if it's a centralized forwarding mode, you can see before roaming, the traffic is sent from the STA to the AP send it to the AC. And after roaming, it's similar. STA send it to the AP send it to the AC. Of course, it's centralized. But if it's a local forwarding mode, it will be complex. You can see STA will send it to the AP. Sorry, before roaming, actually before roaming, STA will send it. Let me change another color to distinguish them. Before roaming, STA will send. Okay, STA will send it to the AP, and AP will send it to the some of the device based on the forwarding entries, right? Local forwarding entries. While after roaming, you can see it's a little complex. After roaming, STA will send it to the AP, and AP can find this is a layer 3 roaming, and the forwarding mode is a local forwarding. AP will send it to the AC. AC will send this traffic to the AP before roaming. To the AP before roaming, and then AP1 will follow the forwarding principle of the local forwarding. Means will locally forward it to the maybe to the switches in the network, and the switches will check the local forwarding entries to forward this packet. Okay, this is a little complex. You should know it. How does the traffic forward it at the layer 3 roaming when the forwarding mode is local forwarding, or the forwarding mode is a centralized forwarding? You should know the difference between them. Okay, and next about the roaming, let's see. Next is about the configuration. No matter at this page, no matter it's a layer 2 roaming or layer 3 roaming, you can find that all the APs is managed by the CMAC, right? All the APs is managed by the CMAC. And in this case, the roaming technology don't need to be configured. Okay, don't need to be configured. Means that by default, the roaming inside one AC, right? Or we call it, it has a name called intra-AC roaming. The intra-AC roaming, or the roaming inside one AC, is already enabled by default. We don't need to manually configure it or manually enable it. Okay. So even the working principle of it, or even the data forwarding of after roaming is a little complex, but the configuration is quite simple, right? Even for the scanner rails, which only have one AC, we don't need to configure the roaming at all. It's enabled by default. While next is the inter-AC roaming. Inter-AC roaming means that we have two ACs, right? Let's see, we have two ACs, AC1, AC2, and AP1 is associated with AC1, AP2 is associated with AC2, and let's see how does the traffic forward it. And this is the this is an inter-AC roaming. We have two ACs because in some cases, we use we have a large number of APs, and we can use maybe more than one ACs to manage them. We can tear the APs into different parts and use different ACs to manage them. Or in some cases, we have ACs in different layers. For example, we can divide the network into different layers, and we use the layered ACs to manage the APs. For example, AC1 is used to manage the APs at the lower layer, and AP2 can manage the APs at a higher layer, and at the same time, it can manage the AP1. can manage the AC1. Okay, this is the situation when we should use some maybe more than one ACs. And then let's see how does the traffic forwarded and at the inter-AC layer 3 roaming, and the forwarding, actually the forwarding mode here is the centralized forwarding. Okay, this is a centralized forwarding mode. After roaming, you can see the traffic is directly sent to AC2, and AC2 will send it to AC1, and AC1, since before roaming, the traffic is also sent to AC1. So after receiving this packet, AC1 will maybe check the forward entries and maybe send it to the egress, to the gateway. Okay, this is the inter-AC layer 3 roaming at the centralized forwarding mode. Okay, and at this time, actually between AC1 and AC2, they're going to establish a cap-up terminal. So we should know that the cap-up terminal is not only established between the AP and AC. In this case, between the AC1 and AC2, they will also establish a cap-up terminal. Okay. Okay, this is an inter-AC layer 3 roaming, and how does the packet forwards? Okay, I see a question in the group chat. It says that I use the AC controller only via cloud. Okay. About the question, you say you have two different APs managed by the cloud, and if you connect with one of them, the band is 2.4. If you connect with the other one, the band is 5 gigahertz, right? Actually, it depends. It depends, because most of the APs nowadays is door band. Okay, door band APs means they can support 2.4 and 5.8 gigahertz at the same time. And if you didn't distinguish them into different SSIDs, because for some of the APs, you can, when you connect to the Wi-Fi, you can see, for example, employee 2.4 gigahertz, employee 5 gigahertz. If you didn't distinguish them, the terminal will automatically select. Okay, terminal will automatically select the band based on the, for example, based on the power of this radius, or the power of the signals, and some other parameters. They will select by themselves. Okay, and want to enable guest captive. Do we need to buy AC for it works? Okay, and the next question is, you are using RG-RAP2260, right, and managed by the cloud. You want to enable the portal, right, portal authentication for the guest. You don't. It's not necessary. Actually, it's not necessary to have AC. The portal authentication is also supported. It's also supported on the cloud. Okay. On the cloud, so you just need to enable this function on the cloud. Okay. Any other questions? Okay, if you don't have maybe other questions, let's just take a break. Okay, if the portal is not showing, maybe there's something faulty actually. So you should do a troubleshooting to find out the reason based on the real situations. Okay, but yeah, but this function is supported. Okay. Okay, so now let's take a break for about 10 minutes. Okay, please come back after 10 minutes. we will go on later.